Hello once again, fellow YouTube viewers. This is Robert again doing another tutorial on another program. The program that we're going to be doing a tutorial on today is going to be Google Earth. And we are not doing a normal YouTube video like you'll see a lot of different locations on how to use mapping or how to use anything else. We're going to be doing a tutorial, oddly enough, on how to locate stars or planets for setting up a telescope or for whatever reason you want to do it. A lot of times we have in the news that Mars will be showing at such and such time today, or this eclipse, or this or that or the other. Plus, sometimes we just want to look for particular stars, maybe star patterns that we're looking for to show our kids, and we want to set up our telescope. And today we're going to show you how to use Google Earth to find that location. And what we need to do first to find that location, we need to find it and how it exists parallel from the location that we are setting up the telescope. So what we're going to do first is we're going to find out the degree or angle from the center of our axis of the Earth to where we are located, and then we are fixing to minus that or plus that, depending whether it's north or south of us, from wherever the star is located. And we'll show you how to find the star in a moment. But first we're going to show you how to locate the degrees that we are from the axis. So we're going to zoom down on the North Pole. You'll see where all the pictures, the panoramic pictures, are kind of bringing down together at one point. You'll see a little like a starburst here. What we're going to do is we're going to go up here to the ruler, and with the line we're going to create a dot, and then we're going to pull it to where we're going to be setting up the telescope. Let's say we're setting up the telescope in my home city, which is Bogalusa. So we'll go to Bogalusa and drop the dot. Now that line is showing a length of miles from the top of the axis. We're not worried about the miles, footage, or anything else. What we're worried about is the degrees. We show 59.25. We're going to go ahead and start putting this on a notepad. And 59.25, I believe it was. Yes. So now what we're going to do is I'm going to show you why first we're doing this. So this will make a little bit more sense to you. What we have in whole is we have a line from the top that leads to here. Imagine a line that runs through the center of the Earth, and from that line you have a line that comes out. Now the 59.25 represents the angle or the degrees that we ourselves are from the axis. And what we need to do now is find out what angle the star or planet that we're looking for is going to be. So we're going to go ahead and go to sky, appear on the planet, and then go to sky. And pull the ruler out, go ahead and clear it. We want to find the North Pole. If you didn't already keep it there, it should have already been marked here. But if you want to find the North Pole when you're looking at this array of different stars, the easy way to do it is at your North Pole here, align your North Pole up, your little compass up here, and then begin to scroll upwards. Keep an eye on your N, and at one point your N will flip and begin to turn into your go south. Then you know you're lined up on the North Pole. You see a little starburst, same thing that happened on the North Pole of the Earth. You have a little dark energy search thing here, and Polaris, the North Star. So we know what we're looking at is we're standing directly on the North Pole and looking straight up to see it. So what we're going to do now is we're going to go ahead and draw that line with a ruler. Click it right there. What are we looking for? What planet, what star are we looking for? Whatever you're looking for, whether you find it from zoomed out mode and you're just looking around, or you type it in. Let's say we're looking for Mars. Now the camera is going to take us to Mars, and as soon as we locate it, we'll get the degrees from the top of the North Pole to Mars. And now we're going to click it there. It looks like in degrees we're looking at 96.38. Bring our pad back up. And what we're going to do here is 96.38 minus 59.24. And let's just do that on the calculator right quick. So 96.38 minus 59.2, whoops, 37.24 would equal 37.14. 37.14. Now I'm going to show you why this is our angle. So this just makes perfect sense to you. We're going to create a circle. This is the Earth. A line through the Earth. This is the axis. Not exactly at the 23-degree angle here, but this is your axis. And now on the Earth we had a certain distance that we were located. And that distance, let's say it's not right there. Let's say it is right here. That angle would be our 59.24. That would be our angle. But now we're looking for a planet, and what we want to do is we want to set this as our zero platform. This is where our scope would be set on. We would be setting the telescope on this angle. Okay, but where our planet is, let's say it's represented by this line way out from the Earth. Now, the distance between this line to this line is how we would set the telescope to view what we want to see. So that angle would be 37.14, and that would put us dead on what we're looking for. You can use this on any star pattern, but since the Earth does rotate, it will not give you the exact time that it should be lining up. So though you may be facing directly south 37.14 degrees, you're still not going to get your exact time when that's fixing to line up. But I do thank you for watching this YouTube video, and y'all have a nice day.